Have you ever been stuck troubleshooting an equipment issue in the field? If only you had more information to solve that problem. Now you do, thanks to Watermark. Watermark, a leading manufacturer's representative devoted to giving you concise and informative tips about how you can solve that equipment issue quickly and definitively. Go to ewatermark.net to view their library of troubleshooting videos. That's E as in excellence, watermark.net. Welcome to Scaling Up, the podcast where we're scaling up on knowledge so we don't scale up our cooling towers. Yes, folks, last week we were talking about cooling towers with Evapco's Brett Alexander, and Brett is back with us today to continue our conversation about cooling towers. And I've heard from several people out there that they learned quite a bit about cooling towers. I think the number one comment that I received is everybody calls something that resembles a cooling tower, but now we know, depending on what it's actually doing and how it does it, it's not necessarily a cooling tower. And we have some new names for those. Well, as I mentioned, Brett is back today, and we're going to continue our learning endeavor about everybody's favorite piece of equipment, the cooling tower. Well, Nation, my returning lab partner is Brett Alexander of Evapco, and last week we learned all sorts of new terms. A lot of us just call everything a cooling tower. We learned that there were different terms for what that device was doing. We learned about the water and air interface, and we even learned about the different metallurgies that the towers can be made out of. Well, today, Brett has come back, and we're going to talk about some of the designs that we have in today's cooling towers. And you might think you know what they are, but there are some really cool things out there. And the one that I want to start off with, Brett, by the way, before I do, how are you doing today?
I'm good. Good to be back. Feel like we got the weekly service visit thing going right now.
There you go. Coming back every week. We'll see if you come back next week or not. We'll see how much we get through. But I want to talk about drift eliminators because I am fascinated in the differences between the drift eliminators from yesteryear to the drift eliminators from today. And as I'm speaking, I'm realizing that there are probably some people in the Scaling Up Nation that don't know what I'm talking about when I use the term drift eliminator. So do you mind talking a little bit about those and what the differences in today are?
Yes. And all evaporative units should have the PVC drift eliminators, is typically what you'll see. So think of like the tower fill, the PVC fill that water's flowing down through. Well, above that, you will also have a layer of PVC called drift eliminators. And so all it's doing is it has usually about 3 different turns in that PVC. So when the air, that saturated air, after it comes in contact with the water, is flowing up through the tower, it will go through those 3 passes of the drift eliminator, and then any moisture that has been caught in that airstream will stay behind in the tower, right? Eliminating the drift. But you're not completely eliminating drift. There is still some drift that is going to happen. And so there are different percentages we as the evaporative cooling manufacturer give the different units. So we can get into a couple of those if you want to.
I'd love to, and I'd like to talk a little bit about why I'm excited about the drift eliminators and the very little drift that happens today. And quite frankly, it's because of Legionellosis prevention. And I want to talk a little bit about the term that I just used was Legionellosis, not Legionella. Legionella is the bacteria, so we still need to treat that. There needs to be a plan. All of that needs to be in order. The drift eliminators do a great job in minimizing the risk for that Legionella to come out of the cooling tower so somebody can inhale it and then get Legionellosis. So can we talk a little bit about that?
Yeah, that's a very important topic. I always refer to the reps and the contractors and engineers who are kind of designing these projects with cooling towers. The one joke I like to, this is not a joking matter, but the kind of thing to lighten the air I give them is we don't ship any of our cooling towers with Legionella in them. is kind of our public service announcement. But once you put water in them in the field, that risk is there. And so what we do from the manufacturing standpoint is we add drift eliminators into that top section to keep those water droplets in and not exit with the airstream. So what the drift rates, they have gotten significantly better over time. So the modern drift eliminators, they can be as low as 0.0005%. So to calculate how much drift you have, you would take the 0.0005% and you would multiply by the recirculating rate. So whatever that condenser water pump is recirculating the water at to get your drift you would see out of that tower. So that 0.0005%, that is as low as you can get on counterflow type cooling towers. So I talked about that last week. Counterflow is when you have the water flowing down the fill media and the air is coming up the fill media. So they're moving counter of each other. So the water to then escape would have to turn 180 degrees and then go up with the airstream. So it's harder, right? It's got to do a complete 180 and go up. So that's why your drift rates are going to be lower in counterflow type cooling towers than in crossflow. So to reiterate that point, crossflow, you've got the air coming on two sides and the air is coming in and it is going across the falling water. So they're moving perpendicular to each other now. And so now all the water has to do is turn 90 degrees to get in the airstream, those water droplets. So it's easier to kind of turn and get up in the airstream. So you'll see a little bit higher drift rates and crossflow towers compared to counterflow towers.
Now, if somebody has an older counterflow tower, can they refit them with the newer design drift eliminators?
Yes, they can. So that's a huge talking point and somewhere that water treaters can even add value because you're out there every month looking at the tower, hopefully doing, a walk around and inspection. And every so often you could even go up or talk to the operator and be like, hey, we should go up and inspect the drift eliminators and make sure they're there, two, they're not damaged. And then what year were they manufactured? What are the drift rates? Because the modern ones are now, down at 0.001% to 0.0005%, where the older ones could be only at 0.01%. So, a significant difference by upgrading to the new modern drift eliminators can really help keep that water inside the tower.
So if you're up there and you're looking at the drift eliminators, you definitely shouldn't see any algae or anything on the top. You shouldn't see any wetted surfaces. What else should you be looking for?
Make sure they're all, placed, they should all look uniform across. Like it shouldn't be kind of cockeyed, sitting up on one another because that PVC, when you take it out, it takes a little skill getting it back to fit in properly. So you've got to look at that, make sure they're all sitting down on there. And that's kind of the main thing.
Something that we like to do is on a regular basis, we'll go up, we'll take off the easiest piece of drift eliminator that we can access, making sure that we've either turned off the fan or whatever we needed to do to keep ourselves safe. And then we look down below that to inspect the spray nozzles. So I thought we would just bring this up since we were talking about looking at the drift eliminators, but what should we be looking for with the spray nozzles?
Yeah, that's important also because you need to take the drift eliminators off, as you mentioned, to look and see the spray nozzles because there's different spray nozzles. And so some are more prone to getting clogged up. And that's a concern, right? Because we know from water treatment standpoint, chemistry, if you're not getting adequate spray coverage over that fill, you're going to be more prone to having a wet, dry surface. And then you'll see deposits start forming, right? Scale, if it's not continuously wet in that area. And then we know what happens. Usually the water treater gets blamed that the water treatment's not working. Well, really, it's the spray pattern. You're not getting the full area flow over that fill media. And so that's a huge point to make sure you're getting enough flow rate through the nozzles to give enough coverage, but also those nozzles are not clogged up and you're just not having a certain area in the fill that's not seeing water, or it's seeing water sometimes and then it's not. So you're getting the wet dry effect, which is leaving behind scale and deposits.
Is it called the EvapJet, the one that you guys demonstrate with ball bearings actually going through it?
Yeah, it's got a huge orifice opening. It's like 1 inch wide. So they put mulch through it. They put like marbles through it. So it's really easy. Like you're having to put something pretty strange up there or through your water system to clog up one of those. So those have been a nice technology advance in the spray system for towers.
Now, is that something that can be retrofitted on other towers or older towers?
That depends because the spray systems are kind of dependent on the inlet piping to it. We can retrofit a lot of different towers. Like it doesn't have to just be a Vapco tower. It could be one of the competitors. What I would say is to listeners and any of the water treaters out there is if you have concerns or you have, questions about the constructions or the spray nozzles or the drift eliminators, we have Evapco reps and service groups all over the US and Canada and in Mexico. And they are happy to come out and, do those unit inspections and see, what parts, that could help upgrade and keep that tower running efficiently and safely. And so they're always happy to get leads from the water treaters because you're the ones that are out there every day. So I try to tell them, make sure you're giving the water treater leads because he's going to give you part leads when he's out inspecting the towers.
Well, and the great thing about having that relationship, as we were talking about last week, is now you're not going to get a surprise that a new cooling tower has been sold because they're going to let you know.
Exactly. Yeah, it's really a great relationship. If you can get in with a contractor company or a sales representative company that does a lot of work with cooling towers and coolers, it can really help increase your business.
We were just talking about the wet-dry evaporation. So high concentrated solids water is splashing over an area and maybe a nozzle is clogged. And now all those salts are now exposed until it gets wetted again. And of course, everybody thinks that scale and the water treatment chemistries aren't working. It could be that the nozzles are clogged, but I've also seen where people have put variable frequency drives on their pumps and they've allowed that water to slow down so much that we're not getting good spray over the tower fill, and we see the exact same thing. What can we do about that?
Yeah, so our general rule of thumb on our open cooling towers is we say we can typically turn those down 50%. So, if you're rated for 1,000 GPM flow rate, we're saying you can turn it down on that same unit to 500 gallons per minute and still be good. So people sometimes want to turn it down 25%. But then, like you said, you're not going to get that coverage over that fill. And then we're going to start seeing deposits form and the salts start caking up on that PVC fill. So I think then you push them back to the end user that they should probably consult their representative that sold the unit. So then they can get the factory's involvement and the factory can give the recommendation what the actual water flow rate turn down should be. Because we are educating all you right now, on these different things. And I understand it's difficult sometimes when you're there a month and you give this information and then it kind of, gets forgotten about. But I think it helps when you have that representative or that person that sold it and they get an email or a call from the factory. And like Evapco says, you should only turn it down to 500 gallons per minute. You're at 300 gallons per minute. That's out of, our recommendation. And I think that carries a little bit more weight with it. And so we get those questions a lot. So we're always here to help.
Yeah, it's definitely helpful when we have information from the manufacturer. I'm thinking of accounts that we had an issue with and the customer bought a variable frequency drive because they wanted to save energy. And I think they were putting less than 10% flow through this unit. And the high concentrated solids they were evaporating out and the solids were left on the fill. And they were saying your water treatment chemicals are not working. Why aren't they working? And we had to explain to them that it was an operational issue. And what I had them do was just turn it back on to 100%. And within a day, actually, I think it was within that same day, we then turned the unit off, let it dry, and you could see that our products were able to break all that stuff off pretty quickly. So that was how we demonstrated and got them to turn that VFD up so it could actually get full coverage.
Yeah. And when I'm hearing VFDs, what we typically see these on is on the fans, right? So you're not ramping up and down the flow rate as much. Your first thing, the energy savings is on the fan motor. So you're ramping up and down the fan speed based on the load and the ambient outside temperatures. So, cooling towers that are going out today, our reps are also selling some VFD package to go with those fans.
That's a great point. And I think the people in the nation need to realize that, the point of the cooling tower is to allow us to concentrate up the solids so we can use as little water as we can to properly operate that system. But when we slow that water down, all the solids that are just suspended in the water, they're going to separate out. And then we can also start to precipitate out some of those concentrated solids, and that can create issues in other parts of your system. So I think it's safe to say that variable frequency drives make a lot of sense on the fan, but you better know what you're doing if you're installing them on your water pump.
So Trace, my coworker, I was talking to him about this podcast the other day and what I was going to talk about. And we were talking about, varying the flow rate through it. And he goes, Brett, the thing is, cooling towers love water. Like when they have water and they're seeing the water they're supposed to, they usually run pretty well, So it's just as simple as give the thing the water it needs and you have the good water treatment program. Usually things work out.
I think that's a great way to look at that. And people, they're trying to do the best that they can. They don't have all the information, so they're thinking they're saving energy. They don't realize what the other shoe is that will fall from that. So that's where we become involved, and that's where getting good information from the manufacturer allows us to deliver that information to the end user. Brett, I am sure there are listeners out there that now immediately know what we're talking about when we mention the word louvers. And that's the piece on the cooling tower that the customer will look at and say, hey, their scale on these, your system is not working. So those are evaporative salts. Those are areas that have gotten wet and then evaporated. But there are so many people out there that do think that those are scale. And I just want to make sure that that's not scale. It's fair to say that something's scaling up when it's in a 100% wetted area, but something that gets wet with high concentrated solids water and then immediately dries, that's not scale. That's evaporative salts. So I said all that to load you with this question. Sometimes those louvers will get so covered with evaporative salts and then organic material. And how much can you have on there before it starts disturbing how much air is actually going into the cooling tower?
You need to have the airflow through there to cool the water that's flowing down through the fill. And these open cooling towers are giant air scrubbers, right? They're scrubbing in whatever's in that air. And a lot of that will get deposited on those louvers. And so there should be some type of maintenance program where they're either going out with a power washer and washing those off. Another thing, what I've seen people do is they have extra louvers. And when they start getting dirty, the ones that are installed, they take them off and they dump them into the cooling tower basin.
I advise all of our customers to do that. Buy one extra of each size louver, leave it in the tower basin, and your water treatment products will clean that up for you. And you just rotate them out on a monthly basis.
Yeah. And then you're not risking power washing at a too high pressure and breaking the PVC.
And I've seen that more often than I would like to. You see a big hole in the PVC and you're like, okay, well, that's not doing its job.
Yeah. And so thinking back when I was kind of a newbie down in Austin, Texas, I was out at the airport. That was one of the accounts. and their louvers were constantly getting dirty, and he was just didn't understand it. And what's going on right next door is construction. So the dirt, the dust, and the construction, all that up into the louvers, and so no wonder they're getting more dirty at that time of year.
Well, Brett, we've talked all over the map when we talk about the anatomy of a cooling tower. So can you help summarize that so we can all visualize it a little bit better?
Yeah. So an open cooling tower, right? I explained it last week as a big metal box, but it's got PVC components that make it up. And so the PVC components that we talked about are the air inlet louvers, where the air is introduced into the tower. And then you have the fill media, where the water and the air interact, where the heat transfer takes place. And then above that, you have the drift eliminators, which job is to keep the water droplets inside of the tower. And then you also have the water distribution system. That's usually a PVC pipe with spray nozzles to spray the entering water over that fill. So those are kind of the general components. And then, of course, you've got your fan and your fan motor above the drift eliminators for an induced draft cooling tower. That AWT Young Professionals presentation, it has these images and it has circles of the different components of a tower that kind of lays it out so you can visualize it.
Well, I think that cleared things up for a lot of people. Let's get into why everybody tuned in. They want to know what they can do from this conversation about their water treatment programs. So now I, as a water treater, am talking to an equipment manufacturer, and I want to know, what does the manufacturer consider to be a good water treatment program?
Man, that's a loaded question. I'd say one that doesn't cause corrosion scale issues where I'm getting the phone call.
Fair enough. So whether we're treating it or we're the manufacturers of what we're treating, we have to deal with corrosion, we have to deal with scale, we have to deal with microbial fouling, and we have to deal with the dirt and debris that's coming in the system. So that doesn't change no matter where you are on the fence.
All of the equipment manufacturers, us and the competitors, they all give water chemistry parameters based on the materials of construction selected. So this is a table that I'm looking at one right now. It has the property like pH, conductivity, alkalinity, calcium hardness, chlorides. And then if it's galvanized steel, 304, 316, what the recommended ranges to keep that water chemistry in. So if you're ever in doubt, I would reference those first to just make sure you're kind of staying in line with the recommendation of the manufacturer.
Yeah, and I'll even say that takes precedence over everything. Whatever the manufacturer says that you need to maintain, that's what you need to maintain.
Yeah, and the one I would want to point on is we have chloride ranges on there, or the upper limits of chlorides, but that is highly dependent on temperature. So say you have a stainless steel open cooling tower, you can maybe push the chlorides up to 500 at, when it's seeing 85 degree water. But you put that in an industrial process and now it's seeing 110 degree water. I'm not recommending pushing the chlorides as high. And there's definitely there's a chart. I can picture it now, the chloride limits that you can have based on the cooling water temperature. And that's a good thing to reference.
Do the recommendations change dramatically from manufacturer to manufacturer?
They're all pretty much the same. I would say we are probably more conservative in places because we actually have a water treatment division. So we actually kind of, to be blunt, know what we're doing. I think the others just kind of follow suit a little bit. So honestly, when in doubt, I'd kind of turn to the Vapco one.
So what are some of the things that you've seen out there that you think every water treatment program should include?
So when I think of a full water treatment program, I think of one for the dissolved solids, which we all do, right? You got your scale and corrosion inhibitor, and then you got some type of biocide treatment. And then I'm also wanting to have some type of filtration system in there as well for the suspended solids. And then on top of that, some type of water management plan that has offline tower cleanings, inspections, testing if that's required in your area. So, you got to have the dissolved solids, you got to have the suspended solids, and then you've got to have the plan in place that encompasses the entire water program.
Yeah, and when you speak of water management plans, you're speaking specifically to Legionella in whatever system that you're referring to.
Yeah, they're being more recommended in areas. The CDC came out with that SC 17 and 30 thing for hospitals a while back, where they strongly recommend having the water management plan, because I think they went back on that and they don't require it actually, but it's a strong recommendations of hospital and healthcare facilities to have that water management plan in place. But I just think it's a good idea because a lot of those parts of it, with the offline tower cleanings, some type of maybe disinfection, and then, at least the inspections, you're giving yourself a better chance of success for your water treatment program as a whole.
I'm curious, how has your life as a manufacturer changed since ASHRAE's 188 has come out and been adopted by New York?
We get a lot more requests for tower information because they have to register all their towers in New York City now. What we've seen, which is kind of one of the topics I wanted to talk on, is we've seen a lot more of overfeeding of oxidizing biocides in units. I don't want to put this the wrong way. It's like, I understand because, some places have regulations about when you need to feed an oxidizing biocide and, to what residual if you get a test count over a certain range. But I think some people are kind of taking advantage of that in the sense that they now feel they can overfeed to just make sure they're not having that bacteria count. They're trying to do the right thing, right? Keep the tower safe, try to minimize the risk of the Legionella bacteria growing inside. But that is coming at the detriment to the tower metal, at which we're seeing. I'll give you one example. Earlier this year, I went up to New York State, and this boarding school had a couple induced draft counterflow open cooling towers at them. And we got called up there because they were starting to see some signs of kind of leaking, kind of weeping out of the basin, out of the corners, running down. You can kind of see the staining on the outside of the basin panels. And so it kind of got into play, like, what's going on? Are we having a water treatment and operation issue? Is there issues with the welds? So I went up there with Chris, and first thing you do, you introduce yourselves, all the parties, the water treatment company, the manufacturer, the end user, the sales rep who sold the towers. And you kind of, you're not up there to, point fingers. You're just up there to gather data and see what's really going on to help the customer. And so at this specific site, what we found is that the leaks or the weeping on that tower were only in these two corners of each of this. Was a 2-cell cooling tower, and it was when you walked up, they were at the two corners of each of the cells that face each other. And what this water treatment company had been doing is they had been dumping a granular DMH biocide into that basin, just for kind of a little slug feed, a little shock feed every once in a while. The issue with that is the way that basin is designed. It's kind of got a step in it. So he was dumping it on the step portion of the basin, and then down below, then it drops off to where it sucks the water out.
So they weren't using a feeder of any kind. They were just dumping it directly on the basin?
They did have a feed system also, but their reasoning behind this was he was doing this to stay up with the New York state regulations, which I'm not an expert. Those things there's so much information out there on those and, different ways to look at it. But what we found is they didn't have to be doing that. They didn't have to be shock feeding up to a 5 ppm residual and recirculating it as often as they were. and especially the manner of how they were doing it. Because when they were dumping in that solid biocide, it was just settling into the bottom of the metal of the basin and just sitting there. And it really wasn't a good mixing area. Where he was dumping that in is where we were seeing the leaks. And so that's just kind of, I wanted to let everybody know, you just got to be careful where you are slug feeding your chemicals, if you are doing that, and where you do that, and then what type of chemical it is. If you're doing a solid chemical biocide, you got to be very careful where you dump that into the basin and make sure you have good mixing.
Yeah, ideally you have some sort of feeding system so you're not having those granulars just sit on the raw metal. Yikes. Especially an oxidizer.
Yep. And so that's just, you got to just watch the overfeeding of the oxidizing biocide, because the corrosion we've seen is what's happening definitely in New York City and state because of those new regulations. They're getting interpreted by different companies on how to do it. And we're seeing the oxidizing biocide feeds go up to levels that are not safe for the metals of the system.
That is a great point, because there's so many people out there that they want to do the right thing and they don't have all the information. And your guy's a perfect example. Hey, I want to protect people from getting Legionellosis or Legionnaire's disease, so I'm going to put this extra product in. But he didn't really understand that, hey, if we have 10 parts per million of chlorine for an extended amount of time, we're not going to have any equipment, so we're not going to have to worry about any Legionellosis. But at the same time, too, we have to learn how to apply those properly. So my hope is, and New York responded in the way that they knew how, but as different municipalities adopt a program to conform to ASHRAE's 188, that they look at all systems, not just the cooling tower, but then they also consider that we've got to take care of the equipment as well as the people that are around the building. And we have to come up with a way that involves an education component and just all the parties understanding what's going on, because people just reacted in New York to the legislation. And there's just so many things that I think other municipalities can learn from that. And I think your example is a great example of that. Well, we started this by talking about what's considered some of the things that you would want to see in a good water treatment program. Let me reverse that question. What are some of the things that are issues or could create a bad water treatment program? I know that there's a multitude of things that you can choose from. So maybe top 3 or 5 of some things that you've seen that just create an issue that's just so hard to overcome with water treatment.
I would say you'd be surprised. We see a lot of different from no water treatment where they just like, we don't need it. It's never been done, and then they're surprised why their coil is failed in a year and a half.
Now, in this day and age, how can that be? How can people, because we run into them as well, but how can people think still that they don't need water treatment?
So I would say the one thing I've seen on some of our units, there's 2 things that really come to mind when I think of this. Is one, it's zero bleed systems. I haven't really run into a system out there, maybe because an issue hasn't come up, but a lot of issues have come where a tower is cycling up to 50 cycles and they're wondering why they're having accelerated corrosion on these towers. And I'm seeing these zero bleed, no blowdown systems in areas where they're really water efficient constants. They have either really high water bills or they have a hard time getting the water supply. And this has been very detrimental to the service life of the equipment. We might be saving water, but the metal is getting stripped away at a much higher rate than industry standards would like us to be at. That would be my first one. And then the second one is I see a lot of softeners being in play as a treatment, softening the makeup water to a cooling tower or a closed circuit cooler. That's great because a lot of the times, this, hardness in the Midwest is high. And so you want to knock it down to reduce the scaling potential. The issue with soft water is when you're making up 100% softened water to units that have galvanized steel, that is a corrosion issue for that zinc. So we'll see companies that are softening the makeup water and then they have a galvanized coil in that closed circuit cooler, and they're seeing the zinc stripping off of that coil quicker than if they were just using the regular city or well water. So that's one thing we've kind of been educating the industry on is do not use 100% softened water to make up a unit with galvanized steel. You could split stream soften it, but it's just it's a risk with that. You might be helping from the scaling perspective, but from the corrosion end, you're hurting the unit.
Now, when you say split stream, what do you mean by that?
You're softening the water, but then you're blending it back in with some of the raw city water or well water. So, maybe you have a 200 ppm of hardness coming in on the city, and you're going to blend that back in with your softened water. So you're doing a 50-50 split. So that's just more of a controls thing. So that's great in theory, but it takes a nice, a well set up softener system to be able to do that correctly.
So if there's a member of the Scaling Up Nation out there listening and one of their customers has come to them and said that we want to create this impossible scenario where we don't bleed any water or we're softening all the calcium out of the water, what is a good way for them to be able to talk with their customer and say, hey, here's some data that I have from the manufacturer, or here's what I've learned, and we need to really look at this and make sure we're not just addressing one side of the coin, we're addressing the entire program?
With the zero bleed thing, I think the way to go against that is use the manufacturer's recommended water chemistry parameters. And I'm pretty certain if they're cycling up that high, they're going to be above a few of those properties. Probably calcium hardness for sure, alkalinity, and maybe even chlorides. So, that kind of takes them out of warranty. And then from the softener perspective, that is also in the O&M, the water chemistry table. And so we have, for galvanized G235 steel, a minimum of 50 ppm of calcium hardness. And I see this all the time where, people with a galvanized coil are running a purely softened water, and you're seeing 1.5 to 2 ppm of zinc residual in that recirculating water. So they're just constantly stripping the zinc off the coil, which is problematic because that's your heat transfer surface. And that's where the money is of that closed circuit cooler or evaporative condenser.
Now, Brett, let's say that this member of the Scaling Up Nation did all of this and the customer still says, nope, this is the way that we want to do it. Would you recommend that they document that it's outside of the parameters of the manufacturer's suggested water parameters? It's their equipment. They can do what they want with it, but we document it so they can't come back to the water treater and say, you're not doing your job.
Yeah, that's a big point. It's good to write in the report, definitely, because then you have the paper trail. But it sounds like the first thing is you go have that discussion with them, because we know, what's the percentage of the plant personnel that are reading the reports, right? Very low, probably, but you still need that paper trail. So you want to have that discussion with them. Say, hey, I've talked to the manufacturer. I've talked to the sales rep who sold this equipment, and he talked to the manufacturer, and they confirmed we're operating outside of OEM. So this is a concern. I'm seeing this, and then this was what will happen. Whether it's a scaling concern or a corrosion concern, I think it's good to tell them, what they're doing wrong. But then you got to reinforce it with, if you keep doing it this way, this is the outcome, and then put it in writing. And I know we beat our heads against the wall sometimes when you do that. I get calls from the people we partner with around the US on, trying to help people, operate their units in a certain way with regards to the flow rate, what kind of makeup water they're using. So all we can do is recommend. And at the end of the day, the customer is going to do what they want to do.
I just think that's a great point to make, because sometimes we'll just hit our heads on the wall trying to get somebody to do the right thing. But you got to remember, It's their thing and they get to do whatever they want. We just have to make sure that we protect ourselves if they choose not to take our advice. Well, I started off asking you what was some of the bad things you saw with water treatment. And I know there's just a host of items that you can list. Something that I want to ask you about is why are there so few cooling towers out there that do not have filtration on them?
I think the cost thing, everybody is very cost sensitive now. And so, having a competent water treatment set up, for the scale corrosion bacteria, on top of having some way to filter out suspended solids. I mean, you're talking about a pretty good upfront cost to a new installation. That's not to say we still see quite a bit of setups that have filtration. And so where we're trying to lead the discussion and help out on the front end is we'll actually build the open cooling tower and we can factory install sump sweeper piping in the basins. And so if you've ever been now to an account and you look and you're inspecting the basin, like I hope you are, especially with stainless steel, right? Keep those surfaces clean. If you look in there, you might see PVC piping running along the basin floor, and it might have some nozzles. And what this is to do is you'll hook that up to a filtration system, whether it's a centrifugal separator or a sand filter. And so you're pumping the water through that filtration system, and it is flowing through those nozzles, spraying the dirt and debris down to a portion of the basin where it sucks it out, goes through the hydrocyclone or the sand filter, removes some of the suspended solids, and then that water goes back into the inlet of the sump sweeper piping system. So it keeps that dirt and debris moving in the basin floor while also sending it to a filtration system to remove a portion of those suspended solids.
I just can't get over the fact that people just don't understand that chemistry cannot overcome a mechanical deficiency. And if we do not have a filter to get out all the stuff that tower that you described as an air scrubber earlier is just washing out everything that's coming in with the air, we can't be expected to get good product, whatever our water treatment program is, to whatever that metal surface is if we can't get to the metal surface. So I don't know what the answer is other than making sure that we just have dialogue with our end users to let them know how important filtration is on these systems, because without it, we're just fighting an uphill battle.
Yeah, and how it works is I keep saying, sales rep, because with Evapco, we work with representative companies all over the U.S., and they are the ones that have the right to sell our evaporative equipment, right? And a lot of them also have filtration packages, whether it's sand filters or centrifugal separators. So if you're able to find those guys in your area or, on the account you're at, they are the ones that would be if they sold the cooling tower, they're the ones that might have the say or the ear of the contractor where you're like, hey, I recommend you have this filtration system set up. I know you want to sell it, right? You make money. You want to have the system as efficient as possible. And so I think if you can kind of get on their team and on their side and you guys work together, that's how you can kind of get more of those packages in where you have the filtration and the water treatment on there together.
So Brett, last week when we opened up the show, you said you had some tips with towers and evaporative condensers that could help the Scaling Up Nation. Do you mind sharing those with us?
Yeah, so everybody's familiar with the open cooling towers setup, right? The large water volume, connected usually a plated frame, heat exchanger, or a chiller. So we mentioned last week about the closed circuit coolers and the evaporative condensers with the coils. So I just wanted to touch on a couple things to keep in mind when treating those units. Typically, those units, when they're outside, you'll see them with a spray pump right by the unit, and then it is connected to a piping that goes up the side of the unit that's called a riser pipe. That's what transports the water out of the basin up to the top of the unit and then sprays it over the coil. So what we see a lot is people trying to tap off that riser pipe to bring supply water to a conductivity manifold or a supply line to then inject some chemicals into it. I just want to give you a heads up that those riser pipes, usually are very low pressure. So you might be only having 2 to 6 psi of pressure when you are tapping off of that. So depending on how far you're trying to bring that supply water to your water treatment setup, you might have issues getting it back into the basin of the unit. So you might require like a booster pump depending on the size of the run. So just keep in mind the low pressure of that riser pipe on closed circuit coolers and evaporative condensers.
Brett, let me ask you, I've seen systems where people have tapped off the riser pipe and then they've drilled back into the side body of the cooling tower to allow the water to return to the basin. How do you guys feel about that?
That's a difficult thing because we sell water treatment stuff that are factory mounted on our units. So I kind of have the point. This is one where I'm conflicted, where I, try not to give too much recommendations on where you should drill holes in our units. So the one thing I will say about that is you need to make sure when you're returning it to the basin or in through like the louver, or then through the PVC part might be the best spot. That supply line should make sure it goes below the coil. Because what I've seen in the past is you tap off the riser, you bring the water flow, and then you got some injection nozzles where you're feeding your low pH, maybe corrosion inhibitor with a biocide, say a bromine-based biocide, and then you return that water into the unit. I've seen it have enough pressure actually, where then when it returns in the unit, it's going in there at a pretty good flow rate, and it was spraying and hitting the coil. Well, that coil ended up getting burnt up at that area where the water was hitting it because you're getting that concentrated chemical additions to that supply water to your treatment setup. So just be careful where you return the water into units with coils. Make sure it's getting directed below down into the basin. So a couple other quick ones. These units, because they have the spray pump and the riser pipe on them, the closed circuit coolers and evaporative condensers, that is, with the coils inside, that they have a much smaller water volume. So what that means is they are going to have a high water turnover rate, right? They're going to cycle up quicker and you're going to be bleeding water. So if you're going to be using a non-oxidizing biocide, you're going to need to do one with a faster kill. So the recommendation would probably be DBMPA. I'm not sure if ISO or GLUT would be able to have any effect unless you're locking out the blowdown for an extended period of time. So just keep in mind, it's a lower water volume and a higher turnover rate in these units.
Now, you make a good point of how quickly evaporative condensers with a very small volume can concentrate up. So listeners, you need to make sure you understand how much concentration that's going to happen when you're locking out your system, because you might actually go above what a particular ion can stay in solution. So just keep that in mind as well. What other tips do you have for us, Brett?
Yeah, I'd say the last one is we call these the closed circuit coolers and evaporative condensers. When they have the spray pump out by the unit and the riser pipe, we call them integral sump. So all that recirculating water is right out by the unit. So what that means is your water treatment has to be out by the unit, right? So it's just something to keep in mind, where if this thing's on the roof and, you're lugging up pumps and pails, or, what type of inventory you're going to keep, you might have to do 5 gallons or, solid chemistry type systems, because it might be quite the hassle getting up 15-gallon drums up to a roof of these units.
Great tips. Well, Brett, I really want to thank you for coming on not only this week, but last week. You shared a lot of information that I'm sure has cleared up misconceptions within the Scaling Up Nation. But let's just say that there's a water treater that just got in the car right now and somebody was listening to it. What's the one thing that you want to make sure that everybody gets from this conversation?
I think as water treaters, we all know how critical it is to fully understand the makeup water quality, but it's just as important to understand the equipment that water is going to come in contact with in the cooling system. We talked about different materials of construction, galvanized, stainless steel, different types of units. So they all have different things you got to keep in mind when treating them. Don't take a cookie cutter approach from your one central plant with this large field directed cooling tower to a small data center with a closed circuit cooler with a galvanized coil. You've got to have different approaches to each. And you got to know the temperatures they're running at too, to make sure you know what type of treatment system to put in place there.
Yeah, there's so many people out there that will look at the bulk water temperature, so the temperature in the water that's circulating, and think that that's the temperature. You know, if we're talking about an evaporative condenser, we're most concerned about those top coils where that hot ammonia is going through, and sometimes those can be in excess of 190 degrees.
Yeah. Well, anywhere from 150 up to 190, like you said, and that's where you're going to see your deposition, and then we're at risk of chloride pitting up at those top rows of coils.
Yeah, I love that. That's great advice. Know the systems that you're treating. You know, we're called water treaters, but we really should be called system or equipment treaters, because that's what we need to know. Brett, I'm curious. I know there are a lot of people that want to learn more. So where would you advise they go so they can continue this learning process?
So we've harped on it a couple times. I would say you can reach out to the AWT or the CWT certification thing with that young professionals presentation we did. I think they have it in PDF format, or I know I have it in PDF format. So I'd be happy to share if we can do that.
Yeah, that'd be great. I'll put that on the show notes page.
It's just nice to be able to see the images we're kind of talk about and kind of put the different components with an image. And then I have all the tips from the water treatment of the different units on there as well, and the different types of units, so it's all laid out in a kind of PDF PowerPoint format.
Perfect. Thank you for sharing that with us.
And then, just all the manufacturer's website have that O&M material. So the checklist of what they should be doing with tower cleanings. So you're beating your head. They won't do the tower cleanings. O&M says the recommended tower cleanings. They have schedules on there. And then also the water chemistry parameter tables. So you can get all that stuff online.
Great resources. Well, I'm almost done with you, but I do have a few lightning round questions. So are you ready for those?
Yep, I'm ready.
All right. So you now have the special power where you have the ability to go back in time and visit yourself on your first day as a water treater. What advice would you give yourself?
Yeah, so I've listened to a couple of your podcasts where you've asked this before. And so I was thinking the other day, I was like, well, definitely the one that makes sense is like everybody needs to slow down. If you've got, 30 plus accounts, it's kind of like the rat race. So I wanted to think about, something a little bit different. And I think the one that also is very important is setting expectations early on with the customer. And what I mean by that is, you go out there and you meet them for the first time, they might be expecting different things out of you. And what I ran into at this one data center is anytime there was an excursion with, the biocide feed, we were feeding on ORP, they would want me out there, within 24 hours. And, sometimes that's just not realistic. And I kind of felt trapped into, having to do that for this data center. But I think if you set expectations early on in the account, you can then manage that better. So you don't have to go out there right away. That would be one thing I would tell myself.
What are the last 3 books that you've read?
So I'm a big sports guy. So I read that John Grissom Bleachers book. Quick read. It was entertaining. And then I also like kind of some type of leadership books, but also kind of the just being a better person type of books. And the one I liked was the 4 Agreements. And it's kind of cool. It's about kind of Toltec principles and just like doing like good things, being a good person leads to, living a good life. And the 4 Agreements are be impeccable with your word. Don't take anything personally. Don't make assumptions, and then always do your best. And
well, that's just good advice.
Yeah, those can always apply to your everyday professional life. And life with your family. And number 3, right? I'm reading one right now, The Leading at 90 Below Zero, that one about the Antarctic Mike. He went and did like a marathon in Antarctica. So I just started that one. But one thing I heard within the first 20 pages, he had a good line. It was like he was explaining what he did as a recruiter to people. And it seemed like so boring. And I've heard people mention it's kind of hard to explain what we do. What I took for that from the first 20 pages of that book is you just need to be enthusiastic about it and just, be like, hey, I help people solve problems, on a daily basis. Instead of talking maybe about cooling water treatment, people are like, huh? You kind of just like tell them like something you're passionate about, what you do. And so I kind of wanted to take that. And now when I get asked that question, be able to respond in a more positive manner.
If we were to look at the podcast subscribed list on your phone, what would we find?
Fantasy Footballers podcast. I'm big into fantasy football. And then yours, Scaling Up. Those two.
I wasn't fishing for that, by the way, but thank you.
Yeah, well, you caught it.
So you may not know this, but Hollywood listens to Scaling Up H2O, and they find next year's movies by listening to this podcast. So they are currently writing the script about Brett Alexander. Who do they cast to play you?
So I feel like they'd have to spice up the movie, if they wanted to do my actual life. So I kind of into like vampires and zombie movies. And the one that came to mind for me was, I think it'd be cool if like Wesley Snipes played me from like his role in Blade. I'm going out every day to like these boiler rooms or central plants, and there's vampires or zombies that you're having to deal with. So I think it'd be Wesley Snipes.
That's an interesting movie premise. So I'm looking forward to the vampire water treater coming out next June.
Stay tuned.
My last question for you is, you can now talk with anybody throughout history. Who would it be with and why?
I think it'd be somebody I wanted to like relate with from like maybe a leadership and, going through adversity standpoint. You go back, being a chemical engineer, you're like, could it be somebody in history that did something like significant with our industry? And I just don't know if I'd really enjoy that as much. And so I just went with a easy one. I'd want to just sit down with Michael Jordan and just go over what went on with his life and, how he got to be a world champion so often, and, just kind of pick his brain about leadership.
Well, Brett, thank you so much for coming on Scaling Up. We've covered a lot of ground. It's been over 2 weeks, and I'm sure we could probably do another episode and still talk about different items with the cooling tower. So we might even have you back to do that. But I know we have helped a tremendous amount of people within the Scaling Up Nation. Thank you so much for that.
Yeah, definitely. I'll be at AHR, the ASHRAE convention in Orlando. So come over to the VAPCO booth and say hi and bring questions.
So we're going to be there too. So maybe I interviewed you last year. Maybe I'll do that again.
Yeah, looking forward to it.
All right. Thanks so much.
Thanks, Trace.
Brett, thanks so much for coming on Scaling Up H2O and sharing with the Scaling Up Nation all of that information and helping us out with some of those terms. Nation, Brett sent to me all of the items that he mentioned in the interview, and he also sent me some extra items too. So if you go to scalinguph2o.com, go to this episode's show notes page, you will see a whole bunch of stuff that you can grab. There's information on white rust, control parameters during passivation. He also sent us the presentation that he mentioned during the interview. So for those of you that do training from this podcast, a great recommendation would be to download that presentation and now do a training presentation on all the information we talked about here on today's show. Brett, thanks again for sharing that. Evapco has been just an outstanding partner for me. When I was the president of the Association of Water Technologies, they gave us such great material to use as we were developing some of our technical papers that we were working on. Chris Nagel, Brett, all of the fine folks in their water division have just been incredible in both development and sharing information. You probably remember Chris Nagel. He was on Scaling Up H2O 2 years ago, and we were talking about white rust. Evapco has an entire lab devoted to water treatment, and they look at things like white rust. Now, the great thing about them is they don't just keep that information to themselves, they share that with the community. And Chris did a great job of talking about what they do in the water lab on episode 37, and he shared some documents on that episode as well. So I just want to thank Evapco for all they've done for the water treatment community, all they did for me when I was president of the AWT and helping get information. And they continue to give papers and presentations at different events like the Association of Water Technology's annual convention and expo. So guys, just thanks so much for all you do. And we're going to say, hey, keep it coming. It's great stuff. We're learning from it. And thank you for putting it out there. I also want to thank the Scaling Up Nation for listening to this podcast, for sending in questions about what you want answered, people that you want me to interview. But I especially want to thank you. I know you are going out and you're finding other water treaters, people that would enjoy this show, and you're letting them know how to subscribe to this podcast. Thank you so much for doing that. So Nation, thank you for all that you do. And as always, I will be back next week with a brand new episode of Scaling Up H2O.